In this lecture, we will see the height of a binary tree. So, as you can see, this is a tree representation in which this represents head of the binary tree, or you can say as a root of the binary tree. And after that, each edge, or you can say each next node, can be considered as the height of a binary tree. So, if I count this edge, then this, and this comes to be 4. So, in short, if you tell what is the height of a binary tree, it comes out to be number of edges from the head or the root of the node till the bottommost node can be considered as the height of a binary tree. You can count from this side also, like 1, 2 and 3, but this is not the maximum height. Maximum height will be this, 2, 3 and 4. So, 4 will be the output. So, we are going to see how we can get the height of a binary tree with just 2 lines of code. So, first I will create an explanation. So, for that, let's create a method in which we will count the height. So, for that, I will just print out the height of a binary tree. So, I will call it height and pass the head of the node. So, I will create this method. So, it will be created. So, if I go to this method and I will pass it here, so you can see it represents set of characters. Instead, I will print the height. So, I will be returning the integer. So, now the thing is, the main function in which I will be calculating the height of the binary tree is this. So, the head is the same head which I have passed it here, that is 2. If I see, I have created this head and passed the node 2. The same node structure is there, that is the data and the left and right pointer. So, I have represented the head with 2 and I have represented the same replica, and now I have passed this head in the height calculation method. So, the thing is, first check is to check the edge cases, that is if the head is null or not, that is head is not equal to null, or you can count head equal to null, then just return -1, that this is not the height, simply return -1. Otherwise, what you can do, count the left height and the right height, and the maximum of which will be counted in the next iteration. So, you can count left height equals, again call this same function recursively, the same height function, and pass the leftmost pointer of this current node. Simply you can do count the right hand side of height, that is right h equals height, and pass the head dot right pointer. So, whatever the maximum which will be coming out from this will be the result, like int result equals 0, and you can check if, or you can remove this pointer, we don't require, if left height dot data comes out to be greater than, since it's an integer only, greater than right height, then simply return left height +1, else you can do return right height +1. So, what we are doing here, we are checking that what is the left height recursively from that particular node and what is the right height from that particular node, and whichever comes out to be the maximum, we are returning by appending 1, and in the last you can append -1. So, that's it. So, we are just returning the height of a binary tree and it is not reachable, so removing that, and we are just printing the height. So, we can write in a better way, that is height of tree is, and just add the height of the binary tree. So, let me run this as Java application. So, you can see height of the tree, it's tree, height of the tree comes out to be 4. What we can do, since we want just a 2 line of code, so we can take the edge cases And instead of creating these two variables, extra variables, and calculating in the last, we can just comment it out, these things, as it will just increase the code number of lines of code in our IDE. So let me just do one thing, that is return simply height and head dot next, that is the leftmost, and height head dot right. So whatever the data comes out from these two, I am going to simply take the maximum of these two. So how to take the maximum of these two? Take math dot max, you can call, and append just one from that. That's it. As you can see, this is a two-liner code. What we are doing, just an edge case, we are checking whether it's null or not. If it's null, just append -1. Otherwise, append 1 at each iteration by checking the maximum of left and maximum of right. So whichever comes out at each iteration, either leftmost or the rightmost, just append 1 to that. So if I will run this, it will again give me height of 4. So it's a two-liner code to get the height of a binary tree. Thank you all.